All right, today we're going to be discussing atoms in the periodic table. We're going to begin by taking a preliminary quiz. So everybody needs to get out their science notebooks. I just want you to write down the number and the answer for each question. Now that you've finished your quiz, we're going to get started on our lesson. We're going to start by talking about atoms. Atoms are the smallest parts of elements that can exist alone or with other elements. They contain 3 different subatomic particles. The first is a proton. It has a positive charge and it is located in the nucleus of the atom. The second is a neutron. It has a neutral charge and it is also contained in the nucleus of the atom. And the nucleus is just the center portion of the atom. The third subatomic particle is the electron. It is a tiny negatively charged subatomic particle, and it rotates around the exterior of the nucleus. The electron configurations, the first electron shell contains up to 2 electrons. The second, up to 8, and those are the 2 we need to worry about today. A neutral atom is going to contain the same number of protons as electrons. That's what gives it a 0 charge. And an ion is formed when one of the electrons, when an electron is either added or taken away from the atom. So to review what we just discussed, Lauren, can you name part 1, or number 1? It is the positive
proton.
Okay. Michelle, could you name number 2? See here?
It's the electron.
Skylar, can you try to answer that question?
Oh yeah, it's the neutron.
Correct. And Lexi, what about number 3?
The electron.
Very good. And here we have the periodic table. Notice how each of these boxes contains one element. Each of these elements has an atomic number, a chemical symbol, a chemical name, and a relative atomic mass. In this periodic table, we have the states in which these elements are found in nature. So if it is solid at room temperature, it has this black box. If it is liquid at room temperature, it has a droplet of water. If it's a gas, it is represented with a cloud. And the man denotes that it is artificially made, and this denotes that it is radioactive. Here again we have the periodic table. Here we have the group names. Group 1 is the alkali metals. Group 2, the alkaline earth metals. Group 3, we skip over the transition metals. We move on to group 3, which is boron group. Group 4 is the carbon. Group 5 is the nitrogen. Group 6 is the oxygen. 7 is the halogens. And 8 is the noble gases. Now what a periodic table is it's a chart of chemical elements that displays the elements in rows. And as you go across the row, it increases in atomic weight. When you move down a row, it increases in valence electron shells. So this period, this row, will have a maximum of 2 electrons. This row will have a maximum of 8 electrons in the valence shell. And a group is one of the columns on the periodic table, which I've given you the names for, and they share similar properties because each group is going to have the same number of valence electrons in its outermost shell. And the a period is a row across the periodic table, and it has the same number of electron shells. And here we have the box, the element box that gives you the atomic number, the element symbol, the element name, and the atomic mass. Now, the element is a substance that cannot be separated into simpler substances by chemical means, and that is represented here. This is the element name. A compound is going to be composed of two or more elements. So an element is one, and a compound is multiple different. And your atomic number is going to be equal to the number of protons in any atom. And your element symbol, which is here, is a 1 to 3 letter symbol denoting the element. And your atomic mass is approximately equal to your protons and your neutrons. So your equation for the atomic mass would be atomic mass equals protons plus neutrons. And this is important because your atomic number is the number of protons in the atom. So to figure out how many neutrons you have in an atom, you take your atomic mass, you plug in your atomic number for your protons, and then you solve for your neutrons, because it's not always going to be equal. In many of the smaller elements, it will be. You'll have the same number of protons and neutrons, but as the element size increases, there are many elements that have different numbers of neutrons than protons. Okay. So I need you guys to get in your groups, and you'll need one sheet of paper. And what we're going to do is we're going to draw an element. Each group is going to be assigned an element, and you need to draw it with the correct number of electrons, the correct number of protons, which is given by your atomic number, and the correct number of neutrons, which you will find by taking the atomic mass minus the atomic number to find your neutrons. You also need to include the element name, the atomic symbol, the atomic number, the atomic mass, and the state that the element is found in nature, as well as the group that that element belongs to. An example of this is here we have magnesium. Now, drawing it in the nucleus would be difficult. So here we've got 12, it's got 12 protons and 12 neutrons. And since the electrons in the first electron shell, it can only contain 2 electrons, we have 2 there. And then this electron shell can contain up to 8 electrons, so it's full. And then we have to go to the outer shell to put those last 2 electrons. Here we have the element name, the element symbol, the number, the mass, the state that it's in, and the group name. Okay, so group 1, you'll be drawing beryllium. Group 2, I want you to draw carbon. Group 3, you need to draw oxygen. Group 4, draw neon, please. Group 5, you have lithium. 6, boron. Group 7, nitrogen. And group 8, you've got fluorine. Now, when your group has completed this project, it needs to be turned in to me at my desk. And once everyone has completed this, you'll complete a worksheet where you will match the definitions of your vocabulary words to the vocabulary words. You will fill out the the structure, the diagram of an atom, filling in the subatomic particles, labeling them, and labeling the electron shells. And you will also match the group number to the group name. All right, get started on the projects, please.